In this video, we'll be looking at the face swap and body swap workflows for the MiniMax H3 model. The face swap result looks good to me. Let's quickly go through the workflow. Before we proceed, the custom node used here is from Abel Jones. Click here to get the required custom nodes, and while you're there, give the project a star. As we always do, just clone the project into the custom nodes folder. You should also pay a visit to this contributor here. Some of you may already know him since he has released multiple custom nodes in the past, and they work really well. For the second workflow, the custom node used is from this repository, and it looks like the project has been updated again for the third time since I started looking at the code 4 days ago. All right, back to the workflow. In this section, the nodes and connections you see are pretty common for reference to video workflows. I have the model selected for reference. Next is the Comfy UI Kitchen Attention, and then I'm using the 8-step LoRa. You can also use the 4-step LoRa. I just wanted to check the difference in quality. Below is the condition node with the reference image of the girl, and the image is coming from the left section of the workflow. These images were generated using the Flux-Klein workflow that I showed and shared in one of my previous videos. The prompt used here is for generating a character sheet. The image then goes through a background remover node, and this is a small model used for background removal. I will add the download link later, place it inside the models, and then the background removal folder. Both images are stitched together, which you can preview here. The conditioning then goes into the K-sampler, and the output is decoded to get the final result. The main difference here is the empty latent used for the video, which comes from the node group below. So we have an LTX node that prepares the video latent by taking both the pixel frames and the audio. These 3 nodes are responsible for creating the video latent, while the 3 below are responsible for the audio latent. The audio comes from the left side of the workflow. This is where the original video is uploaded. The video is then resized using the Resize V2 node, and there's some mathematical calculation happening inside this subgraph. So that takes care of the audio. Above that, we have the video latent, which is the output from the set latent noise mask node. The pixel video is taken above, while the face mask is taken in the below node. This allows the diffusion process to work on the masked area while using the given image as the condition. You do need to give some guidance to the video generation by pointing to the reference image using the label Picture 1, just like I explained in my older video on the H3 model. Both the audio VAE and video VAE are placed below and connected to the conditioning node as required. Then, in the latent section where we encode the audio, video, and mask. Finally, at the decoding stage to get the final video. And that's pretty much how this workflow works. On the right, we saw the original video being resized, along with the math calculation happening inside the node group. You can leave this as it is. The number of frames used by the conditioning node comes from here, and the width and height of the video are also provided here. These are required connections for the node to work. However, the empty latent output from this conditioning node is not actually being used. The empty latent used to generate the video comes from the node groups below. Let's look at what happens to the original video and the nodes responsible for creating the mask. The video frames coming from above are used in 2 sections. This is the first one, and then the second one. Here, I'm using the SAM3 model. I've provided the link to the model below. Place it inside the checkpoints folder. Next, we have the prompt used for segmentation. It's a simple one-word prompt, head, and it works. The tracking happens inside this node, and below, you can see the head being identified in every frame along with its object ID. These IDs correspond to the color assigned to each object detected in a frame. If the tracking breaks across multiple frames, a new color and ID are assigned to the detected object in the next frame. The smaller number shown below is the object's detection confidence, displayed as a percentage. It's only shown when the confidence is below 100%. The tracking data is then converted into a normal comfy UI mask, and after that, we have a cleanup node to clean up the mask. The SAM3 model tracks a person, but occasionally it may select a small patch of wall or background. This cleanup node maintains the person stays selected and removes the temporary false selections. So it helps prevent the model from changing areas you never intended to. There are two methods to do this. First is the shrink grow. This is a general choice. It removes tiny and thin noise, then restores the surviving object's original shape. It works if you have some random spot or mark that appears around the subject. Another option is components, which remove blobs that are small and are detected and removed if found inconsistently in a few frames. This threshold, if you understand the mask, which is about brightness level, it works based on the same brightness level and decides what counts as part of the subject. The shrink works with unwanted details. Min frames remove unwanted blobs unless it lasts for these many frames. It affects the video flicker. Edge grow slightly expands the retained subject to protect soft mask edges. The value recommended is 4, but I had to increase it. I don't think you need to go into details on these settings unless you are a developer. The default value works, and this is the only change I made. So, after cleanup, the subject area is cropped. This node crops the video frame around the masked subject, such as close-up of the person, and it keeps the crop stable from frame to frame. When processing the video in the K-sampler, the focus should be on the person instead of processing the entire frame. A smaller focused area can make results more consistent and can reduce the workload needed for the result, which is more efficient. It also helps avoiding the jumpy camera effect that happens when the mask moves a few pixels from frame to frame. There are 3 modes to crop. Combined does a fixed crop that covers everywhere the subject travels during the whole clip. It should give a stable camera framing if the subject does not travel too far. Next is tracked. It follows the subject but moves the crop only when needed. It is like a general choice for a walking or moving person. It will maintain the subject in view. Zoomed follows both the subject's position and apparent size. It can be useful when the subject is moving toward or away from the camera. It can feel more like an automatically controlled camera, so preview it for unwanted zoom movement. After cropping, the B-boxes and the cropped masks from this node can be used to place the processed result back to where it belongs with a feathered edge. The other settings with noticeable effect are crop scale. It is about how much space to leave around the subject. 1.0 is very tight. 1.5 gives a safer margin. Larger value will show more background. Aspect ratio locks the crop shape, such as 1.78 for 16:9 aspect ratio. Leave it at 0 to size the crop naturally from the subject. Padding controls how strongly the node tries to keep a margin around the subject during tracked movement. Upscale megapixels improves the result, and the effect is noticeable because it enlarges the cropped area and gives more pixels to work with, but it has a significant effect on generation time and memory usage. After making these changes, disable the K-sampler and other final nodes to check the preview here. And this is just to preview the B-box. So after cropping the video mask, this node converts the mask into a smaller representation. As we know, the diffusion model internally works on a compressed representation called the latent space. The conversion of a normal black and white mask is translated onto an internal grid so that the model can work only on the selected area. Actually, it does more than what we can see from above. A normal mask may look correct in the preview, but it can shift slightly or even disappear in the first few frames. Sometimes this can also affect nearby areas after Comfy UI resizes it for the video VAE. This node keeps the mask aligned with the model's actual editing grid. There's also a note from the developer about gross spatial. This value controls the safety margin around the selected area before the conversion. Positive values enlarge the selected area, while negative values shrink it. Grow temporal works in a similar way, but in the time dimension. The important thing to understand is that these values do not improve the mask. It helps with accuracy. I think that is all in this workflow. The values you saw works best on my 5060 Ti 16GB. You can increase the upscale megapixels for better results if you have a better GPU. This is the second workflow, and the custom node used here is from another repository we saw at the beginning. The character's movement here was a bit challenging, but I got this result in a single attempt. The workflow is mostly the same as before. The model, followed by attention, then the LoRa, which goes into the guider node. The audio and video VAEs are on the left, and the conditioning node takes the image. Everything then goes into the samplers, but the sampler selected here is different, and this node as well. In the previous workflow, I talked about using the B-box to place the cropped video back in its original place. After the VAE decode, the cropped result is placed back using the B-box, so the final video visually retains the same background objects as the original video. The logic for providing the mask latent is also the same, but this one node replaces all the nodes we saw here. Just exclude this one. And this mask option nodes is working similar to this node we saw earlier. The subject crop node is the same as before, and the SAM3 workflow is also the same, and that was the second workflow. To select and replace the full body, change the prompt for the SAM model to something like full body, and the body should be selected. The result looks pretty good. Next, let's quickly look at how we can select one person from a crowd. First, I'll find a good frame where the character is clearly visible. We can do this by skipping a few frames from the beginning and putting a cap on the total number of frames, such as 97. Testing with 97 frames will be much faster. So this test will use the first 97 frames after skipping the first 24 frames of the video. After making a few adjustments because of the character's dialogue, I'll use this subgraph to get the first frame of the video, which is previewed here. The subgraph expects a video connection, so I'll make a new connection for the image frames, and now this should work. Disable these processing nodes and run the workflow to get the first frame. So this is the first frame. This example has become way tougher than it was already due to the number of people standing. The black region of this head will be a problem. Right now, the value for max object is 0, which means it will select all the bodies found in one frame. I will change the value and make it 1, then connect the mask created for the target subject. The detection threshold, when the value is higher, means stricter detection and fewer false objects. Lower value will find more objects, but may include mistakes. The detect interval with the value 1 means check for object in every frame. A value of 5 means check every 5th frame, which also makes the process faster. The SAM model worked, but I'm not sure the H3 model will generate the person from the reference. You should use a better quality image than the one I'm using. I will let the prompt be as it is for your reference and write a different one above. Enable the processing nodes and run the workflow. The result was a failure. The old man appeared after the first second of the video. This is the second attempt. The number of frames skipped are 9, and the actor is now more visible, but still, it is not an easy selection. The mask is connected to the SAM3 workflow, and it worked without any problem. And this is the result.
See those little black boxes? They're called telephones. I'm going to let you on a little secret about these telephones. They're not going to dial themselves.
So that was it in this video. I hope the video was interesting and informative. Thanks for watching, and I wish you an excellent day.